Alright, so sometimes you come across a quadratic that is missing, let's say, the middle term. So in standard form, we have ax squared plus bx plus c equals 0. Well, when we look at these guys, when we're in this quadratic form, we're missing the middle guy. We've got the x squared term, and we've got the constant term, but missing the middle one. So there's actually a shortcut way to get through this, and that is using what's called the square root method. And the square root method is that we take our original equation, so we have our x squared equals 1156, and we know that the inverse operation of squaring something is to take the square root. If you do this to one side, then you do the same thing to the other. One quick trick that comes out of this is you need to remember that that gives us x equals, because the square root and the square cancel each other, they undo each other, a positive or negative. That's the key piece there. So it's positive or negative because think about it. If x squared is equal to 4, then that means x could be equal to 2 or x could be equal to negative 2. Because 2 times 2 is 4 and a negative times a negative is a 4. So either way, and that's why we need the positive or negative. Now from there, what we need to keep in mind is how can I break this down? So give me one moment here. Alright, so from there we need to take a look and see. We're hoping that that'll be a perfect square. So we say second square root of 1156, and that's 34. So sure enough, we get the answer of x is equal to a positive or negative 34. That would be our solutions. The second one would be very similar. Moving right along to something a little more complicated as we move on to this guy right here, and we would have x squared is equal to a negative 169. Well, same deal. We still take the square root of both sides. On the left hand side, the square root and the square cancel. I'm left with x equals. On the right hand side, remember we talked about how coming out of that, the negative 1, that we can think of this as being the square root of negative 1 times 169, which is really the same thing as the square root of I squared times 169. Remember that from 1.2? So when we pull this out, we would get 13i, positive or negative. And so the I squared, the square root of I squared is I, and the square root of 169 is 13. Kind of moving through these, we get to the next one and last one for this particular video, and then we see that it's not set up correctly. It's not in that format where it's a square set equal to something, but we can fix that. We can go ahead and just add t squared to both sides. So at this point we have 18 is equal to t squared, and then we proceed from there. We take the square root of both sides. On the right hand side, the square root and the square cancel. We're left with t is equal to a positive or negative square root of 18. Now remember back to section 1.2, we talked about breaking down radicals like this. And so in this case right here, we break that down and realize that inside of that radical, there's a 9 times a 2. We're looking for perfect squares, remember? So 9 times 2, the square root of 9 is 3, so I get plus or minus 3. And the square root of 2 just stays inside. Alright, so that'll wrap up for right now our first video on square root property.